The Parable of Alien Chess by Luke Smith. A parable on the logical positivist interpretation of scientific models. The parable. Suppose an alien race comes to Earth and wants to observe our games. They are very interested in chess, despite the fact that they have eyes with properties that make it impossible to make out what actually happens on a chessboard. The whites and blacks of the squares and pieces kind of all blur together for them. They can still learn about chess experimentally. They know they can sit two players, a so-called white and black player, down to play it, and they can tell behaviorally who at the end wins. After extensive experimentation, they realize this: 50% of the time, the white player wins, and 50% of the time, the black player wins. We'll ignore draws and first move advantage for the example. The best possible model. A logical positivist alien thus creates the ultimate long-term model of chess as an iterated game. Half of the time white wins and half of the time black wins. Therefore, we can model chess as a simple coin flip. Obviously, a coin flip doesn't necessarily predict an individual chess game, but over time and iteration, the coin flip model of chess matches the data perfectly. While this statistical technique might not be useful for predicting a single game, over the long run and over iterated games, it is the most efficient and parsimonious possible model. The model is so parsimonious, it has no place or need for concepts like chess pieces or opening strategies or really strategies in general. It is as effective and simple as a model can be. Inferior models. Suppose, however, that a crank scientist of the alien race posits that God doesn't play dice, and that chess is a more complicated game despite the fact that the aliens can't observe it. Suppose he even asks around and it determines from humans that there are actually pieces on the board with functions. And he even devises a machine that allows his alien eyes to see the first move of the game. Seeing this move allows him to create a new theory and model the game, one that takes into account the first move, and using this, he tries to generate a new set of probabilities of victory based on that move. The model he makes is, of course, highly arbitrary, stipulated, and ad hoc. In fact, this model is inferior on many inevitable accounts. For example, 1. It is less predictive over iterated games than the coin flip model. 2. It is not as parsimonious or minimal as the coin flip model. 3. It adds new variables to the theory, like chess pieces, that are suspect. 4. There is no known causality behind how the moving of a piece has anything to do with the victory in chess. Supposing that moving a piece somehow relates to the victory of a player is a novel kind of metaphysics, one that seems constantly disproven considering a certain first move does not always guarantee a loss or a victory. Which model is right? Which model is closer to truth? Unlike the aliens, we are not prevented by congenital defect from observing chess. We know the second, inferior theory of chess is closer in the sense that it is aware of pieces and understands how a player's moves contribute to victory. We also know that the, quote, better model of iterated chess games, the coin toss, is only accidentally accurate, and the statistics of a coin toss has nothing whatsoever to do with how the victor of chess is determined. The new model's theoretical categories, such as the concept of chess pieces and moves, if apparently arbitrary in the eyes of the aliens, are getting to the actual underlying mechanics of chess. Even if the model is less effective, it certainly is righter, which will cause fruitful scientific inquiry. The coin flip model is a scientific dead end. Firstly, the coin flip model is constructed statistically, which presents the underlying mechanism as being randomness, and thus unworthy of inquiry. This isn't statistics hoisted above random variation we know to exist, Instead, it's utterly blind statistics that covers over whatever principles underlie it. Secondly, and more importantly, in order to actually approve that model, it has to lose or at least jeopardize empirical solvency and or parsimony. Embracing the abstractions of chess pieces means introducing mess and deviation in some way from the empirical generalization that half of all chess games are won by white and half by black. This is not an abnormal circumstance. The parable here, really an example, is not abnormal. In most affairs of science, whether that be physics or neuroscience or economics or chemistry, we are exactly like the partially blind aliens. This presents a very clear contrast between a simple and parsimonious theory that works and a radical theory that adds new and questionable content at the price of both effectiveness and simplicity, but is nonetheless closer to truth. But science isn't about truth. Yeah, it is, dude. Even if you were pretending that science is about models or just fitting equations and the like, again, the well-fit 50-50 statistical model of chess made by the aliens is impossible to perfect, while the flawed yet more true to reality model does have a potential over the long term to be a superior one as an alien researcher learns more. After exhaustive inquiry, an alien race might not only discover the chess pieces and the full set of rules behind chess, they might be able to predict what moves are good or bad and predict individual chess games. Even on the standards of mere instrumentalism, the mindless positivistic theory is still actually inferior. In this case, can the positivistic alien scientists bear to tolerate an alternate metaphysical theory until it gradually acquires the descriptive adequacy of the pre-existing theory? Local maxima, the plot. One way helpful to think of scientific truth and model accuracy is to visualize an optimization plot, a three-dimensional surface peppered with various mountains and valleys of various heights and depths. Truth is upwards, and the goal of science is to get further that way. Or if you deny truth as being metaphysics, how about accuracy in data or well-fit equations? At the point you're at, you can tell which direction is up. You can tell which incremental changes in your theory or equations move you upward or which little changes you can make to improve your model. That is what incremental science is. After all, don't change assumptions and just fine-tune your equations. The continued fine-tuning is sometimes thought of as progress. Of course, I don't think that this is bad, but it is a very minor and scientifically less important part of science as a whole. But the reality of incremental science is that once you're at a local maximum, a peak on the plot, once you're fine-tuned your equations about as perfectly as possible, it's over. Science is completed. But you might not actually be at the absolute maximum of truth. But you might be languishing on the peak of a local maximum, thinking nonetheless that you are the smartest guy in the universe. Everything next to you looks like a disimprovement. It looks just like the inferior theories of alien chess that posit the existence of chess pieces. From that, you might erroneously conclude that you have found the global or absolute maximum, which, due to the nature of the complexity of the universe and the multiplicity of possible answers and theories, you flatly haven't. Logical positivism is kind of theoretical lobotomy that implicitly tells scientists that they should never, ever, ever change foundational assumptions. Tweaking equations like an oblivious autist is science, and everything else is philosophy or metaphysics or pseudoscience. This amounts to keeping such scientific field on whatever local maximum is closest, utterly unable to extricate itself from that, even when they see on the horizon aberrant data. If you want to understand the stagnation of science, or any other specific field, this is where it comes from. Purposefully bad science. In Against Method, Paul Feyerabend, in what an unreflective mind might misinterpret as a troll, says that it is important for science that people have biases, financial interests, interfering religious and political doctrines, and the like in science. Looking at the plot, you might now see why. When we are stuck on a local maximum, every new data keeps our already optimized model where it is, no matter how low that maximum actually is. What you need to shake it up is an external shock that totally moves our theoretical position somewhere new on the plot, where we can try to optimize at another point and then compare. Basic assumptions. A prudent person should be able to question, am I even on the right track, or am I playing with some model that has a fundamental flaw? I can guarantee you, optimizing for data and fitting math and equations is easy. All theoretical programs are wrong because they make incorrect core assumptions. This is very hard for the ego of scientists because it means 1. Possibly illiterate dilettantes on the internet might see and bring attention to legitimate theoretical flaws. 2. All the years you spend in graduate school counting angels on pinheads in your respective theoretical framework is mostly a waste of time. 3. The borders of science are borders more of a sociological club than being the borders of raw rigor. 4. Most of the scientific work is not meaningful outside of the theoretical framework that gave rise to it.